all of you.
Yes,
Yes, sir.
Good
Yes, sir.
morning. Good morning. Welcome to third day sessions of our FDP on integration and future trends. The first half portion of this session covers the topic incorporating additive manufacturing into curriculum and project and research opportunities in additive manufacturing. For this session, our today's speaker is Mr. Prashant Suryawanshi. So I cordially welcome to the Mr. Prashant Suryawanshi. Before going to start, I'm going just give a short introductions about the sir. He is currently working as a technical support consultant in Dassault System Pune. He has completed his graduation in mechanical engineering as well as MTech in design. He has 15 years experience in production systems. Simultaneously, he has worked as a simulation engineer, and also he is a founder members of 3D Shikshan Institute in a 3D print. So I hand over the mic towards our speaker to deliver his knowledgeable thing for enhancement of our participant. Thank you, sir, and cordially welcome to Mr. Prashant, sir. Prashant, sir, please.
Thank you. Thank you, sir. Thank you for the quick intro.
Okay.
Yeah, good morning, all. So, I think last 2 days you are continuing the sessions on the 3D printings, and I hope you have enjoyed that. So, this is a very, I would say, like a cutting edge technology. So, and it is definitely going to create a paradigmic shift in the academia. So that's where today's sessions is important, because what we are going to see is maybe I think the former presenters they have covered like topics: 3D printing, what is the 3D printing, then types of 3D printing technologies, then applications. So today we are going to cover basically how we can use the 3D printing in the curriculum, and also the what are the research opportunities and the project opportunity you have with the 3D printing. So I will just start the session. So before, I mean, we really go into the main topic. So I wanted to hear, yeah, we'll go first with this agenda, which we already cover. So incorporating additive manufacturing into curriculum. So need of 3D printing, we'll see in short for the academia. So what I am going to talk about, everything is related to the academia. So other speakers may have covered the topics, bits and pieces, but that is maybe industry applications and all. So what we are going to see today is all about the academia or the classrooms, like how 3D printing is helping. Okay. So even particularly case studies also we are going to see, that is particularly the global as well as some local academic institute, how they are doing the research and all. And also our 3D section COE model, which is our live case study. So in short, I will just explain so that you will also get importance. If let's say you are enriched with the 3D printing technology, then how your institute can benefit for that, and how you are in position to handle this industry 4.0 revolution. And the second part of that, like projects, yeah, so we'll quickly touch upon the what are the different areas where you can have a wide research opportunity in additive manufacturing, and different sources, like what are the examples currently, which institutes are doing like that. So with this, I will start my presentation. So thank you, Institute, for calling me for this talk. Let's start it. So just to tell you, like you may be all knowing, because all the faculties here, like academia situation may not be very great, I would say, in India right now. So I mean, for students quality, and there are some inherent problems which definitely we have to overcome these problems to empower the academia in this particular cutting edge technologies, where the AI is creating no, I mean, buzz, lot of buzz. There are it's a dynamic environment, I would say, where the job is changing, job some getting absolute. So whatever the college pass out students, they are not getting jobs. So it is, even industry is looking for some different talent, some different skill set which is industry oriented. So there is always like a industry and academia gap, and now it is widened with this, particularly after corona period, I would say, when the digitalization happens, the technology improvements happen. So this particular, so that's where we have to prepare for, basically whatever the challenges. And as all faculties are here, so it's our duty also to strengthen this ecosystem, right? So basically, if you see this data, I will not go into much detail, but only thing is what is necessary to do. Like, compared to, let's say, foreign education system, we have seen Indian education where it lacks. So basically, industry exposures and workplace learning, which industry is demanding. So I can see from my experience of last 15 years, so what exactly industry needs and how college talent should be. So there is some gaps, so we have to fill that gap, right? So even there are survey reports like here KPMG reports, and all like, there are, if you see this unemployability percentage and all. So it is not the frightening figure, but what I want to say, like, yeah, definitely there is a scope of improvement for these things. So hands-on learning is a key area. Why this is important? Because as a India, we have a, what is called as a demographic dividend. Okay, so which is nothing but this, if you see this curve, so in 2020 to 2040 we have upward slope. What it means, because this is a working age population and this is a dependent population, right? So we have this kind of, so because compared to all others, let's say, the developing countries, we have a largest populations, right? I mean median age, which is working age population, but it is only fruitful when our young population get proper skills, proper jobs, like that. So that's where it is important for all of us, like, to strengthen this ecosystem. Okay, you can see from here, like, almost by 2026, and this is not, this is NASCOM survey. Okay, so they have say like a 14 to 19 lakh, there is almost shortage of tech professionals. So one sided company is not getting right talent, another side is students not getting proper job. But in between that, this is also the figures which really are dark figures, and so that's where we have to improve this. Okay, so how basically, so NAP, which is the National Education Policy, enrolled in 2020, so it has stated that the particular importance of the hands-on learning. It's not about only the 3D printing or experiential learning. So either on any technology, right? So if you see this industry 4.0, so everybody is talking about industry 4.0. So there are different technologies like AI, then cloud, then cyber security, big analytics, data, then simulation is always there, AR, augmented reality. So if you see from the academic perspective, then robotics, then augmented reality, then additive manufacturing, AI, and cloud. So these are the important technology which definitely students need to get the knowledge more and more for that. So basically, I will just quickly cover this because I know like this area might have other, maybe have cover. So right now we are in fourth industrial revolution. So first industrial revolution, it is just like when steam engine invented. So that is industry 4.0. Then industry 2.0 is when the mechanization or assembly lines production. So that started with the electricity invention, right? So that is the industry 2.0. Then industry 3.0 is maybe when the electronics industry booms and automobile particularly. So that is in 1970 period. And now we are in industry 4.0, which is started from the 2016. Okay, it's already I would say 7 8 years over for this. So what is going to happen in industry 4.0? And you have seen a lot of effects after particularly 2019 or 20. So how the technology is getting paradigmic shift, creating in every sector of the life. So what is going to happen is like physical and digital systems, right? So they are actually
Madam,
across
concept
the
of
disciplines
reference
and across the
international.
industry, it is getting combined
Hakikat.
to create this intelligent production. So there is a very lot of
Ada.
things like autonomous
Kai
cars,
salib.
autonomous machines, and you can see the IoT things and all. So the pace at which the products are developed in the market, it is entirely now, it's very different from before corona and after corona. So there are a lot of innovation is happening, and lot of the spaces, I mean, it's a very
हा ना
dynamic thing,
गुन्हा
right?
दाखल झाला त्यांच्यात एक
Right,
तो
so
झाला दोन
in this all things, like we have to prepare our student for the
त्याच्यात ना लिक्विड
handle this
इकडे
kind of
तिकडे
situation
जाताना
without
टेन्शन
getting
येतं.
stress. So what is the foundation for that, like what we can,
अक्के
so
मथुरे
this is some word economic
आमच्या
forum
किसन आहे त्याला सांगू का
when
काका काहीतरी करत
all the
किसन आणि घरनं
big
दोन लोक आहे
education
ना
institute, they
आमचं.
come together and they have discuss, and then they
आमचं
just lay
थोडं
down
काय
this.
सोल्युशन काय
So
अडचण नाही.
since we are in 21st century, so it is called as a 21st century skills. So you can see it has a very much importance on foundation literacy. That is anyway like we used to also get in the past, which is a language, numerical, then scientific literacy, then communication, financials, and cultural things. But along with that, they have included these two things: competencies and the characteristic qualities. So which is about the
नाहीतर
critical
आम्ही आलो नाही
thinking.
का मग
So
मित्र
critical
असं
thinking
काही
and
पुढे
problem
गेलं
solving,
का
this
बरं
is
कारण
very
मिळालं.
very important now in industry. So definitely, if the particular person is, let's say, is a problem solver or the critical thinkers, right? So along with any one of these technology, so he will not get a problem of unemployment.
आणि
That's
सरांची
for
मॅडम
sure. So though the things are changing around us, but you have to hold at least one technology with this kind of competencies
मित्र
like
8 दिवस झाले का
creativity,
नाही अजून.
communication, collaboration, and all these things are very
काय
much
काका
important in today's area. And then characteristics always like curiosity and
कोणाशी.
initiative, then leadership, persistence, and adaptable. One has to be very adaptable,
ओके या
and
नाही
social and cultural awareness. So all this comprises of the 21st century skills, and I would say like it's our duty to imbibe this 21st century skills to uh, among the students, right? Either it's the school going or the institute. So that is very very important.
तिकडे कोण आहे रे.
So now coming back to our topic, like in 3D printing, why now only is a buzz, and it is already creating a lot of things, because earlier you imagine the area before 3D printing. So let's say any students have any idea, but he don't know like how to produce that idea. So how to give that idea from prototype to real product. So because that time we have to depends on the CNC, NC machine availability, and it is a something capital investment. So one cannot think, but now this picture is representing very clearly, like idea is coming here, it is going in the computer screen, and computer screen, I mean, then you are making the files and you can go into the 3D printers, and this is happening. Okay, so this is FDM printer, so you can easily print that. Now what is going to happen in this particular journey is whatever you are thinking here, it's not only thinking left, right? So you are giving that idea. So it's a iteration, I would say, iteration based learning. So first time you think might be okay, this is can be work, but when you print it and you can see, oh, this is not right, the dimension is not right, size is not right, so let me change that or let me modify that. Then you do the some extensive search on the internet, like for the pattern things, what I can improve in that, right? I mean, any particular things, take example of any, let's say, new development of any gearbox. So the, let's say, gear synchro arrangement, how it is. So these particular things, so earlier it was the different case, but now it is a very different case. So so I would say like with the 3D printing, democratization of the innovation is happening. So earlier it may be with the some of the people or some of because of the machinery capex costs involved, but it is now spread across the India in the small small villages also. Students are coming with the small small idea, doing the startups and all. So that's where the importance is, like with the 3D printing technology, uh, it is accessible, right? So market is accessible, and that's where that innovation space is also increased nowadays, either with the industry also or the startup also. So that is where the importance of the 3D printing, and that's where this particular session is like corresponding to how we can incorporate this 3D printing into the curriculum, because it will create not only the engineers, but yeah, definitely the problem solvers, and they can create the real product which brings their ideas to the life, I would say. So as I think maybe almost they have all cover what is 3D printing and all, then how it differ from the traditional manufacturing and all. So it is just a layer by layer technology, right? And we are printing it from the digital file. So that is called 3D printing. And additive manufacturing is the industry word for the 3D printing. So you can either call it additive manufacturing or the 3D printing. So why it is important from the students? Because so far, whatever the problems, real life problems, like let's say any development, new development, which industry usually do. So their product life cycle also very long, right, before this area. But what happens with after inclusion of, so whatever this problem, real problem they are facing, let's say some chattering in the gearbox, now to overcome that chattering, so they have to change the design of the gear. So how they will change the design of the gear? Earlier we have some restrictions, like again we have to go to the CNC machines, and then cost is involved. But now what we can do, we can make a simple prototypes and change the gear structure or the synchronizations of that gear teeth, right? And then you can test it whether it's really working, not working. So equivalent material you are using now for the printing, right? And it is very fast. So that is where the product life cycle also in nowadays very shorten, and that's where the innovations happening at the rapid pace in the industry. So 3D printing actually helps students, particularly even faculty, so to simulate this real problem into the classroom. So what we are going to do, because there are many students, so I think in my intro, one of the thing is like I was the volunteering the law foundation. The law foundation is basically our CSR entity, where there is one program called Made in 3D. So this Made in 3D program is nothing but there are the top schools among the Pune. So they have chosen the 10 schools, and these schools have given some kind of funding and thing, and their objective is they have to create a pseudo startup, right? Pseudo startup, I mean, say they have to pseudo product using the 3D printing technology. So they have come up, you can, I mean, astonishing to see like sixth standard, seventh standard, eighth standard childrens are doing that kind of things. I have volunteered one of the very prestigious school. So I have seen the energy and passion people, I mean, students are getting after the seeing they're actually printing or their own thing. It's not their idea, but their own product. So their way actually 3D printing helps to simulate the real problems, and they are solving like a different problems. Maybe it's a drinkable some problems, water is not available at the remote place. Then some kind of portable machines. So this kind of innovations they are doing. So that is where the importance of I think for the students to learn this technology. Uh, then yeah, because this is experiential technology, and also uh, because like we learn the best when we learn by doing approach, just not seeing, just not hearing, just not, but when we do actual things, so that time our critical thinking and problem solving, that start developing. And that's where it creates the holistic development of the particular individual, and they're prepare more for this kind of dynamic scenario where there is lot of changes happening around us. Again, 3D printing, you can collaborate this technology with other different technologies, and also this we will see in the last slides, like what are the different skills. So you can see the 3D printing is, it's though it's a smart manufacturing things, but it also needs the engineering science, material science, particularly design knowledge. So there are a lot of technology. I will say there are a lot of not technology, but there are a lot of multidisciplinary skills is required. And based on the application of the 3D printing in the different things like automotive or electronics, then you will again need to have that multi-domain skill sets. So that's where, like, if you are combining this technology or you are working on this, you're proficient on this, and definitely it is going to uh, f- uh, make our students as a holistic development, I would say. So now let's say, now what is happening before, let's say, 3D printing come to really the classrooms, and before that what is happening? So you may have heard because when it is already there here. Let me go here itself, and I'll come back again. So in traditional classroom, So it is a teacher centric approach, right? So one way teaching, one sided classrooms, and which somehow it resulted into the, I would say, the rote learning. But I mean, it's a kind of passive engagement which is more visible. But in 3D printing era, so because these all students are exploring the things, like, so it is not a one way engagement, so it is basically active and deep engagement happening. So that is where the 3D printings creates a very deep and immersive experience with the subjects, because what you are going to do when you are incorporating 3D printing in the academia, let's say, instead of providing the abstract information to the students, instead of that you are going to show that models, right? The teaching aid, we will going to see that, like, so which will help, let's say, any helical gear concept is difficult to understand for the students, how the working and all. But if you simply, instead of giving the 2D diagrams and showing that, instead of you just show them actual real helical gear model and then explain them, so it is very easy for them to grasp that concept. So that's where the 3D printing use, and it also helps them to improve your spatial, like a three-dimensional skills and literacy, visual literacy. So both. So if you see nowadays, like 3D printing is combined with the AR, augmented reality, for this creating this deep and immersive experience, and like whatever the things which are very complex, but with these two technologies or amalgamation of these two technologies, then it is actually creating a paradigm shift in the education area, right? So again, 3D printing teaches the important skills for the students, like I mean, how to absorb the failures, right? Because once you are going to print it, so you are going to encounter an n number of problems, like maybe bed is not aligned, so print is failing, and all these things. So in that, you will also understand again the whatever you are thinking, like whatever idea you are thinking. So as I say, like maybe there is a change is needed to fit that idea into the real product. So this is a iterative learning for the students. So, so it will student going to design it, then analysis it, then again print it, right? So test it and again redesign it. So what will happen in this journey? They will able to understand like how product life cycle works, and this is not going to then limit to the only classroom, because I have seen from my experience when I started exploring this technology. Earlier may not be I'm very much like understanding the things, uh, particularly like I mean the like particular products, so how his life cycle is happening and all. But when we do that, there's simple things like your day-to-day life, whatever the, let's say, whatever the toothbrush you are using, so how you can get manufactured, so why this kind of design only, so can I modify this design. So all this leads to the innovation and again entrepreneurships. So that's where actually the particularly it is very important for academia to hands on the experiential learning things. Once students get habitual of that, then definitely uh, they will started gaining more and more problem solving skills, creativity, their experience, experiment ability to do the experiment. So that ability will also increase, and which will create, because if you see the foreign education and the India scenario, the difference is that only. So we also deal with a lot of foreign clients in company, but we have seen that. So maybe our masters is equivalent to their BE, because in their, if you see, this is more on practical things rather than the theoretical things. So definitely there is a long way for our academia also to improve, and definitely as India shining, we are going to improve. But for that, yeah, we have to focus on the experiential learning, and that's where our government also now understand the importance of experiential learning, and that's why that NAP comes in picture, right? Yeah. So why 3D printing, particularly very important, even for the skill set point of view, industry skill set point of view, or employment also, whatever the problem currently India is facing. So that is also going to be at least minimized with the help of getting this technology. Because if you see this graph, right? So this market is clearly shown that this is a green. So this APAC region is the fastest growing region and somewhat saturated market, though this is a very big market for North America and this Latin America, but this is somewhat saturated, like you can see here yellow. If you go and segregate this market further, let's say Asia market, so you can see the US percentage and all, but yeah, I mean it's all market, I think. Yeah, so Asia is at 28%, right? So total APAC. So in these countries you can see India is only about the 5%. This is I think 1 2 years back, so maybe another 2 3%, but below 10% only. Okay, so you can see the how much potential we have, as because we have largest population, right? Then our median age, which is compared to developing countries, median population age is 28. So we have a largest working population, and if we equip them with the right kind of technology, right, so it is definitely going to create more and more innovation, entrepreneurships, and it is definitely India is going to shine, and that's where the government also understand the things. Okay, so though this technology is invented in 1986, so this is the time, I think last 10 years probably, yeah, technology got more mature. I would say it is now within common man reach, because earlier still I think there are some industrial grade printers which is very costly, like in crores, but at least from the students and faculty perspective, they can start with FDM and the SLA technology, which is the resin technology. And with this, yeah, because the working remains same, only the machines and little bit specification materials are different, but at least base remains same. So that is where it is very important for us to gain the knowledge about this technology, and you can see the market size also. So there is a huge opportunity, and it is growing at a 30% CAGR, compound annual growth interest. So there is a huge opportunity, I would say, and even education also you can see it's a positive impact, though there are certain challenges because of that. The CAGR, it is not easy to implement. But yeah, I mean there is a positive curve. Like you can see, there is a growth of almost. And you know how much India percentage for this? It's in, I mean say like a 200 million or so, 200 $300 million. So like that, there is a lot of potential, and that's where we have to use it. Okay, so that's where government also understand it, and then they release the national additive manufacturing strategy, which is at I think primary level. So they were, when it was in 2022, they were saying like we have to add $2 billion to the GDP by the 2025, which is right now is happening. But we are, I think, partially achieve it, and there is lot to achieve, lot to do in this case. But there is a mission of government. They also understand this. Yeah, there are some challenges because this is a evolving technology. So there is some challenges with the material availability. Main challenge with the 3D is the manpower skill set, and that's where once you are able to get these skill sets, and definitely this all things will uh, place in place. Okay, so we were going to cover this, like how 3D printing is an integral part of basically our academia. So it is already coming, already it has a part of engineering syllabus. Even ITI also, they have proposed 1 year course, but it still they have to implement it. And I think soon I think Polytechnic will have, that's where we have this kind of sessions. Okay. Any things? Yeah, please feel to interrupt me. Okay. I know this is a little bit theoretical, but this is important concept to understand, like why that is we are learning. Then, yep. So experiential learning, as I say, these are the different blocks which helps. Basically, it motivates the students, right? Because we are going to give them peer learning, communication. I will not go into all these things. Yeah, then 3D printing for the teachers, yeah, definitely. As you can see here, you can see the difference between these two. Like this is very interactive, and that's where it ignites the thought process a lot more. And that's where whatever the classroom environment is also very active engagement. And 3D printing helps teachers for explaining the difficult concept with the ease, because they're going to use that kind of 3D models. So 3D models, I think I have it. This kind of structures, yeah. So this kind of things. So 3D models, prototypes you can simply use, right? So then, yeah. So even 3D modeling and design skills, yeah, teachers, if they are known the 3D printing, so they can utilize it extensively in their academic progress also, research area also, because basically it will help to develop their competencies, then strengthen their workforce skills and 21st century skills, which we already discussed. So that is also so. This is very important. I mean, you all teachers are like will be the pioneers if this really experiential learnings, if really wanted to make a difference in the education industry. Then how but 3D printing helps for the schools is like since we are all talking about like experiential learning, so basically project based learning, right? So project based learning is instead of learning in the theoretical things, we are doing as a part of mini projects. So already these things are started now in academia, like hackathons and all. But yeah, so focus is on particularly project based learning, so there is help, and then it create helps for the teaching aids, what I said, like test model for the experiments. So there are vast areas based on let's say whatever the streams, engineering, medical, pharmacy, so the different things, we can create a different teaching aid models itself for different things. So again, this robotics teaching means whatever it is, very closely working with particularly robots, which is the education robots and haptic device kind of thing. So development of that, then definitely it is going to, the major problem now with the students with the digital technology is some kind of distractions. So it will helps, particularly experiential learning helps to gain their interest, gain their attention, right? And that's where it is also quite of motivation for them. Again, they can, whatever knowledge they are grasping for the subjects, they can easily implement that, right? If let's say institute has some 3D printers, so whatever the concepts they are learning in the classroom, small concepts, so they can easily try it. Okay, let me print this, let me, there are some websites also ready made available, thingiverse kind of, I think maybe other speakers have covered that. So where you will get a n number of models, not necessary you need to have a design. So you will get directly file. So you try to print that file and see that. So important is how the particular product looks or 3D printing looks, kind of ball bearing also you can see. So there are different, instead of studying the different ball bearing in the, let's say, theoretical way, you can simply print it and you can understand it, inner race, outer race, construction, working, like that. So there where it is important for school to have this kind of arrangement, I would say. Okay, so how now 3D printing is become an integral part of academia. As you know, like ATL labs, Atal Tinkering Missions. So they have missions. They have identified this is importance of the technology, and now I think across pan India, so there are 12,000 plus ATL labs they have set up for the school children. So I mean for the schools. And similarly, idea labs are there for the engineerings, and I think for polytechnics also it may be applicable. So there is a actually 3D printer is inherent. So along with the 3D printing, robotics and all. So yeah, so it is an integral part of that. Yeah. Then you can see the CBSE school subjects. So 3D printing is already has come there. Engineering college, I already told you, like it is already in syllabus. So we also have a required. Now it has come to first year also for the experimentation. Earlier it was just kind of honor subjects for the final year, but now it has come for the first year itself for the experimentation. So that is where the importance is, right? So and IITs and universities, yeah, definitely they're part of the engineering curriculums, and how they are using is a multi actually disciplinary. Okay, so they're not using just for the 3D printing individually, but the combination of robotics and bioengineering. This is a very uh, focus area, very opportunistic area, I would say. and then advanced manufacturing courses. So 3D printing is definitely nowadays is an integral part of academic world. You can think if I would say share this pics when we see the 3D section case study. So the faculty there, they have undergone our course earlier, so they are quite interested for printing the objects. So you can see that kind of enthusiasm is happening in the industrial training institute. So yeah, definitely. So what is creating, basically we are creating the technology thinkers, right? Independent thinkers, because you are doing going to do problem solving and critical thinking and creativity. And how we are doing is validate your idea. So it is not the one way thing. So your iteration based learning. So whatever the idea you are now come up, then you are going to work on that. You are again going to revise that idea. So again you're going to, so in that case, yeah, so the your prototypes you are actually turning into real products, so which is now getting opportunity for the patent things. So there are many college students, they are getting patent right nowadays. So these things is happening because of very easy accessibility of 3D printings, also the printing idea, not only 3D printing but other things also, right? So, and again, this technology, as I said, like it's artificial intelligence or virtual reality. These are the very, very close, and robotics. These three, four technologies are very, very closely going to associate each other and help each other in this technology journey. So that's where there are limitless opportunity for the students, and I don't think any barrier for them. Like whatever the first slide I show, like right now the whatever the statistics, but I think if they are implementing the experiential learning, if institute is implementing that experiential learning, and if teachers playing a pioneer role there, so definitely for their career also and for to student career also, this is going to be yeah, definitely a big thrust, because government is also identified, and so there are a lot of things happening skill in under skill India. May I think industry applications and all other they have cover, so I will not go in that. So as I said, like it is revolutionizing the classrooms. So you can see these different areas where 3D printing can simply helps. So what is doing is like a 3D printing models. So instead of you're going to say, like say abstract information, instead of that you're converting into the tangible models. So the different areas, let's say now this is also reality nowadays, by the way, like 3D printed hearts in research. Okay, I know this is a in the research, but definitely there will be time in future where you will see, because there is already, we are talking about 3D, but 4D printing also has come. So which is also talk about the XYZ and the time. So with the time, the shape is changing, and that technology they are using in the particularly heart, like I mean mimicking the heart or liver, this kind of things. So bioprinting, as I said, is very advanced and very opportunistic area where there are a lot of research happening at the university, foreign university level. Challenge here is to produce that photochemical environment which surround our organs. So but people are finding the way means for that, particularly like which material we can use. So there are a lot of things happening, particularly for bio area, bioprinting. And as you say, the automobile also extensively using, I think Pushkar yesterday covered the applications of particularly automobiles and aerospace, where 3D printing is extensively used. For one thing is for the lightweight, as a lightweight, but same strength or more strength. So like that, the importance, and that's where it's important for students also, right? Once students get hands hold on the particularly technology, and if they not restrict to themselves only the 3D printing or printing stuff, instead of that applications, so how I can apply in, let's say in automobile, or it's in biomechanics, or it's in electronics, then definitely that innovation research, all these pieces will come, right? And even there will be a lot more entrepreneurs than the job seekers. And it is a proven, actually, this whatever the stats I'm showing here, it is from the one paper, is research paper only. So it is proven that engagement is, they have seen there is up, by 30-40%, and 80% positive student feedback. So we have seen, we will cover that maybe in 3D section case study, but we have seen like people maybe is initially reluctant, like I say, like ITS staffs, maybe initially did not understand the fully things because they are not really from the technical background. But once they start using the machines, handling the materials themselves, they print the things, that enthusiasm, that engagement is already, it's built. So similarly, I have seen for the engineering students also, third year, second year students. So that is very important. And for you, like, what are the complex subjects are there, right? Thermodynamics. People will feel, oh, it is really tough. But but if you present that abstract information into the tangible outcomes, so it will also value addition for you, also to the students, because it has been seen like their conceptual understanding, it improves, and the retention capacity also quite drastically improves. So that's where that important things. Again, the STEM career, like science, technology, engineering, mathematics, we say like so technical basically. So more and more people are coming nowadays in the STEM field, and for the tutor, particularly for the teacher, it is having a huge scope. That's where in foreign countries, like professors particularly, they do a lot of research in the STEM field, and there's a lot of products, individual products they do, and then they will have some kind of association with the industry, and like this they do kind of research. So that's where the importance of the 3D printing in the classroom. If anything, we'll go further. Yeah, as you can see here, so there is 3D classes, emoji. I mean, there are co-curricular activities also and curricular activities also. Though I think I have not touched much on this in particular this thing because already speakers cover other applications. But this all about the what you can do with your students or your kids, because I think you are all faculties. So there are a lot of scope simply with the 3D pen itself. So small toddlers nowadays, like simply things like this, instead of doing things on the mobile, they can do these things. So and this kind of monuments and also nowadays extensively 3D printing is used for that, to create the unique, I would say, replica of the models. And then this is for geography, balloon car. This is kind of student made projects only. Then this is the spinning top to explain that population graph. So instead of explaining on the backboard, you can simply use this kind of things, and which is, see, this is ready made available also on the thingiverse site. So it's not necessary everything you have to just design it. Yeah, you can modify it using the Cura the other software, modeling softwares, and then you can slice it using the Cura softwares, and then you can print it. But definitely this is going to make this particularly classroom is more interactive. This is very like a chocolate mold, emoji faces. This is for toddlers, but yeah, this is chocolate molds kind of molding. So once you show them this kind of things, they will also apply in different modes, right? So which is a more like a jigs and fixtures in automobiles. And so you have to start with some small things, and then you can slowly build up them for the jigs and fixture things, then how it is used. And by the way, for the casting particularly, nowadays you know that there are a lot of 3D printings for the large casting models. They are now using different 3D printing technologies. So um, application is huge for the 3D printing, and you have to start the journey at, I would say, at the school level itself. Maybe after I have seen like a fifth standards onwards, they will get some kind of understanding of the design. Tinkercad, by the way, it's very simple software. You have to just play with that software, and you can make any simple things like rectangular blocks and like whatever it is very easy to draft also, and you can simply print that, which enhance your kids or your students' ability to. I mean, because you are connecting them with the real worlds,
हेलो
and slowly they will start thinking
हेलो
how this particular trophy
हाँ
is
बोलो
built. Let me try that. let me try the trophy itself.
बरं.
So instead of buying the trophy from the outside, you can ask your students to print that trophy which you used to give a guest or any guest lecture, something like that. So these
बरं.
things actually helps. So what I'm saying is, you have to be creator. Once you
हो.
start and inculcate the creator mindset in the students, they will also
चालेल ना, भेटून
follow the
घ्या.
same.
हो, आहे ना मी.
So and it will
चालेल,
definitely
चालेल.
help
करून
from
घ्या.
their career,
हो, हो.
right?
येऊ द्या.
So how teachers basically use the 3D printing, like I would say here,
चालेल,
exploratory
चालेल.
print.
ओके.
This is maybe for the schools and all. So uh, how this animal looks and all. So exploratory. Then teaching it. This is important for you. Like vertebra. You know how complex these diagrams when we used to study this biology and all. But with this now, I can easily print that and I can show that functions. So, and it will not take much time. I mean, 7 8 hours overnight. It can print it, small models to show the teacher, so students, and it is not costly also. So because we are using maximally PLA only, so 50-gram filament is enough, I think, for creating some kind of vertebra kind of small models. So that way you can explain them with whatever difficult concept. So there are a lot of application in academia, particularly where the 3D printing is really act as a pedagogy. I would say the pedagogy tool, and it's a very powerful tool, very powerful tool if implemented correctly with and along with other technologies. It is definitely going to change whole the scenario for the Indian education system. But only thing is that at the ground level implementation, how it is going to happen, like how NAPI, you maybe all know, like though it is drafted, I think 4 5 years back, but still people are struggling like at the ground level. So implementation of the technology is very important, and that's where it will start the effective utilizations of machines, materials, and we have seen, we have created the COEs, Center of Excellence models, and we have seen how that ecosystem who slowly start building in a regular college also, not a very top college and all, right? So definitely teaching aid these particular things like how to convert this abstract information into tangible objects. There, like you all faculties need to work on these particular things, and this is important for you, not only for from the student point of view, but for you, like for the research. Once you print it, then you will immediately think, oh, can I do these things a little bit different? Let's say this helical gear, you are there. Can I do little bit some change in here? And you know, never know. This is maybe kind of the patent opportunity. So this thing will start once you see the 3D, and then it will go to that. So that's where in foreign universities always trend is like there are a lot of papers, research papers published, and even patents, and slowly India is also now taking up. So that is very important, right? So definitely I will encourage you to particularly use 3D printing part as a teaching aid. Then the part of lesson, I mean, which half student also can create and you can guide them kind of things, like you can attach here some kind of things and then you can show them. So basically a small model replica of that gear pump things, like how it works and all this. Then mechanical gripper, yeah. So this is a student led and student created. So you can create the the groups of students inside your batch, right? You can give the objects. Okay, just give them something like scratch from the scratch. Okay, you have to design the this mechanical gripper or any robotic component. So then what you need? First you have to design it. Then they will start thinking, okay, then which software do we have to use? So that thinking will start. Okay, this let's say Katia or SolidWorks. Okay, then do we have the knowledge for that? Then if maybe from the group 1 or 2 people, no, then they still think, oh, this is important. Then you can show them, like in industry it's very important, the importance of the SolidWorks. Like you can tell them in the class itself, like how the particularly innovation happens at the industry. So this will help to understand the students, oh no, SolidWorks and Katia, these modeling softwares are important, right? As a mechanical thing, so definitely this is needed, right? And once maybe there are some people, some, because class will be always heterogeneous, so some people good in modeling, some in simulation or testing or practical things, then according to, so it's our teacher responsibility to inculcate and identify the students trait and guide them. So one can be the practical thing. So what I am saying is that that's where that picture I show, right, that interactive classroom. So as a, I would not say, I know like how it's difficult to cover all the subjects in the curriculum time frame and all, but as a kind of mini projects, and let's say if you have some kind of calendar, so definitely these things can be implemented. We are actually implementing that with our course, so definitely this can be done, and at least they will have some kind of glimpse, they will have some kind of hand experience. There will be some mistakes, because when now this gripper and all, so they have to think the motions of this, then they will go to the robotics labs, then they will ask the robotic teacher. So then how to print, I mean how to print that, that is again the questions. Then they will go to manufacturing teacher, manufacturing lab. So so exploration will happen, so that is very very important nowadays. So multi skills and multi, I would say multidisciplinary approach. So that exploration, if students will get on, let's say first year second year itself, then definitely the students will be the entrepreneur. I mean they will think of definitely entrepreneurships, because they have that kind of experiential ability. So they slowly slowly they will the product owner. And that whatever the unemployment problem we are facing, or skill set issues, or typical, because though I'm in industry right now, but I would say there's definitely a difficult time for the industry now, because the innovation space is very very high, and people are not willing to change that. So, and even industry also, it's difficult for larger industry to change to that, I would say, that slope. So that's where if you are inculcating particularly this innovation abilities or entrepreneurship among the students at the let's say polytechnic level, engineering level itself, then at the by the time they will graduate, yeah, they will they have more interest. Now it depends on their interest. One may like milk farm, okay, one may like farming, but they will use the technology. They will use the technology because they have now experience with the exploration different technology, different multidisciplinary, right, approach. So they will not stuck. Oh, I'm mechanical engineer, let me just do the mechanical things. Then who will do the actuator things, right? So they have to go the electronics, they have to go the actuation, robotics. So all these things will definitely, and then whatever the big picture, right, holistic learners, we need a holistic learners, industry needs that. So that will come only when students will have that kind of experience from the different disciplines. And that's where if you see these ENAP things, now they are saying like there is some credits for the different technology. People can change also based on their interest, but it's very important for us like how to retain their retention capacity for the students. So I would say, yeah, and again, they will understand the important concept like first time right is not in reality, right? So though we will always try to make it, but yeah, things will happen. I mean, even in large industries, the things are like that. When the product development comes, so it will start some scratch, some things, some designs, which is we have to scrap ultimately, because we are trying to go into refine, then we are going to do into simulation, we are going to validate that in the practical environment with the test, then accelerating test environment to understand their strength, right? So all these things will happen, and then you're going to refine your designs. So that's where now when you are implementing this 3D printing into academia, so you are actually going to tell them, okay, it is okay to make a mistakes. Now maybe it's our traditional education system where people feel awkward like when made the mistakes, but in foreign it's a is otherwise. Like okay, they learn from their mistakes, right? So simply therefore like we have to also adopt that approach and do the maximum mistakes. I mean, try to minimize the silly mistake, but you will learn in that process, and that's where the 3D printing actually particularly teach you the important things is like a failure. You have how to accept the failure, and it you can connect to all fields. It is not only this academia, industry applications, industry. So failure in another part of the life, even in personal side also. So it will boost their confidence and their problem solving capacity. That is very, very important in this digital area, right? So yeah, we'll go further. So we will see now there's some academia case studies, okay, which is more because others I think cover industrial application, but things are happening at nearby you. So this is for your encouragement, like how we can see here. So you can see the Arunachal Pradesh, which is a very remote, I would say, the state, right? You always see the boundary of China and all. So, but there is also 3D printing has reached, and it's a first India's, I mean, first 3D printing school. So you can see at the government level also there is a lot of push, and this is a top 10 technology, and even Swayam portal. There are a lot of things in under Skill India, NSDC. So 3D printing has that kind of thing. Even yesterday I was searching something, Pandit Ravi Shankar, this rural trust. So they are also incorporating the 3D printing in their even uh, apart from the spirituality things like Swami Samartha Mutt. If you see, to just the main problem before India is like our adult population. So how we can make them away from the all kind of this addiction things, right? Drugs and all things. So they are actually doing kind of robotic sessions. So I mean, again, the experiential learnings. So they are collaborating with kind of our institutes where particularly they're kind of one hour session because it is the platform where a lot of people comes, and if they see okay, robotics we can use or 3D printing we can use, then people will think okay, and instead of that, let me do some interesting work in this area. So like that. Then food 3D printing, definitely this is the IIT, one of the IIT of Tanjavur, right? Food Processing Institute. They have created their own. This is again in future. This I think 3, 4, maybe 2, 3 years down the line, you will see this democratization of this particular food 3D printing. There is some challenges with the material things and some a lot of approvals, FD and all, but definitely this is going to be. And how the hotel person is going to utilize, let's say you see nearby you there are a lot of pizza shops, but if you are creating a pizza very different structures, then definitely it is going to attract you, I mean your kids, and they will say, oh, look how this pizza look like. So kind of marketing also 3D printing helps in kind of this. So maybe not directly we can though it is they said like okay, we can beat it also, and I don't think that is any problematic thing, but yeah, if as a precaution definitely, but for a marketing purpose you can use 3D printing definitely, because 3D printing, the best advantage with the 3D printing is customization. So you can do customization, so a lot of customization, any customization, even you are from the rings, jewelry, all customizations. So that's where people are using it for the customization, right? So you can see here this Alliance University and Wipro 3D is a big name in the 3D printing. So they have now started the MBA program in the smart manufacturing. So you can surprise why MBA is doing smart manufacturing, because as I said, like there is a wide skill gap is there. So that's where we have to fill that gap. So not necessary everybody should go on the machines 3D printing and all, but smart manufacturing, where the manager need to understand where to use 3D printing technology, where not to use 3D printing technology. So that way you have to also understand the skill set of the students and you can guide them. Not necessarily for only for 3D printing is applicable, let's say ITI or the manufacturing level, but even for the MBA kind of thing. And there are a lot of companies like Bharat Forge, Tata Motors. They have their integral setup, right? So they have kind of job role there, which and they always give some kind of advantage if people know the background of the experiential technology. So that's where it is important, and you can see, yeah, this is going to be definitely a paradigmic shift in the construction industries. Godrej, this is, this T Vasta, this is IIT Madras alumni startup. Okay, so they are incubated startups. They have invented this particular cement technology, and now you can see all these things are happening. Let's say either it's a post office, Bangalore post office, first schools, or here IIT Guwahati professors do, I think, security post. And forget about this, in Pune itself, in our Logao airport, that barrack, that particularly where they monitor aircraft and all. So that bunker. So now they have made up it with a 3D printer. So there are a lot of application. As you can see here in biomechanics, I say already, right? It is a very, very opportunistic area. So our biosciences, this is an Indian tech startup. So they have launched this indigenous 3D printer. So far, what is the case? Like we have to import from the other outsides, but indigenously they have created it. I mean, they must have assembled it and then calibrated it. But yeah, you can print the human tissues, and this is also available in COAP. So we have a COAP tie-up with our Make3D lab. So in the industry visit program, we do send people, I mean students, to see how this is, and they will show that like uh, they also able to print the small human tissues. So these biolinks and all they use for that, right? So bioprinting definitely is going to be health sector is going to be a very opportunistic area. Then you can see MIT researchers, artificial intelligence. Yeah, everybody is talking about AI, generative AI. So how 3D printing is related to AI? Can anybody idea on this particular thing? So basically, when 3D printing is evolving technology, so hello, hello, I'm audible, right? I mean, it's not one way, right? Hello.
Yes, sir. Yes, sir.
Okay. No, no, there is pin drop silence. So, okay, no issue.
No
So,
issues.
artificial intelligence basically, see, we are developing new algorithms, right? All advanced algorithms. The challenge with the 3D printing technology, or limitation, I would say, the availability of the materials, machines also the cost and all, but availability of the materials and the printing. So when the new material is invented in the market, right, so what is going to happen is like you have to do trial and error, a lot of trial and error methods. But with the help of the AI algorithms, it is possible to feed some data based on the history, right? And then whatever the trial errors you are doing with that, so that's where it can be reduced, and that's where all these 3D printing manufacturers, I think now it is global manufacturers only nowadays using, but they have implemented this in the research, right? So they are going to use and they can predict even going further. Now 3D printing also comes with, I think, indigenous. There are some higher end printers which indigenous camera and all, so they can predict whether this printing is going to fail or it is going to. So this can things are possibles. Currently, few things are in research, I would say, like how generative AI is doing the difficult, I mean, difference in the market. So similar way. So for generative AI now, everybody like Apple, Intel, everybody starts. All these companies now started doing their tool. So similar things. Definitely, and also for 3D printing is happening, like all manufacturing, all OEMs now they are creating 3D printing hubs inside their campuses itself, because 3D printing, as I said, the democratization of technology. So you do not to depends on the supply chain, which is a incredible difficult happens when the COVID happens, right? And that's where all struggle happen for the industries. But now they understand these things. You can print immediate on order, right? If you have that kind of machines and all. So that's where they're investing in the research. So in a short, like either AI or I mean AI actually very promising if used with the combination of the 3D printing, and that's where the research opportunity also a lot of things, and that's where MIT research. I mean, it's a US MIT. They're actually doing this. So because there are a lot of things when you invented new materials, simple things. I don't know if you know ABS things, which is used for our school, our bathroom buckets and all, or building blocks. So this material, if you print ABS and if you print PLA, so there is a difference, because this ABS is difficult to print. Fumes are so there, like, and it is kind of getting a warpage effect. So how to avoid this? Things again get difficult if you try to print TPU, which is the material which usually we see below a blender, right? The very flexible material. So things are very difficult when you invert it. Again, you can think different, like you can think like a photopolymeric material, which get cured with the help of UV light, like which is using resin technology. So that's where, and then there also, like you can see different kind of flexible resins are coming, hard resins are coming, clear resins are coming. So when we are inventing these new materials, so earlier this 3D printing manufacturing technology, I mean the material supply, they used to get a lot of time, but nowadays also that innovation is fast, and that's where SLA machine price, which is earlier I think 1 lakh or so, now it is well beyond 50,000. So because innovation is happening as the machine material man level everything, and where this AI and 3D printing combination is also helping, right? So that's where the importance of that particular thing. Then I say like bioprinting, yeah, in ISC Bangalore, right? You know, this C-Link is a very global bioprinting, it's a leading company. So they have some kind of tie-up for the biomechanics research conducting with the ISC. So if you are interested in this all these things, so yeah, definitely you can pursue with these things. So I have just covered these academia particular things because I think other speakers may have talked about the industrial applications across the sectors. So I am not going to cover here. I only just you can see here these robotics arms. How this particularly, this is the resin, by the way. This is very clear resins, right? And this is flexible resins also. So you can see there is a vast opportunity in this, even this material development, advanced material development. It is a very depth level subject for the 3D printing, because industry needs applications, but for that materials also needed, for that printers also needed. So basically that whole ecosystem need to develop there. So you can see the group of IIT people come together and they have find out this, which is a geometry based actuator systems, which will contract and elongate, and how it differs from the other artificial muscles, because of there is addition of plates in the actuators. So basically adding the extra degree of motion. So by that's where you can fold that kind of hands, which is not possible, or which is restrictive possible with even with the robotics, but with the flexible resin this can be possible. So academia only doing this, okay. And then this is very interesting. New Mexico patents now just filed the patents for the 3D printing bendable concretes. So usually we use the steel structure infringements also in the concrete. So going forward, I think that is not needed, because bendable is actually providing you a good strength. So that's where there is a lot of, I would say, in foreign. If you see, I would share. I think in last page that there are different news articles and the sites are there. You can regularly follow that, and you will surprised to see that how much research is happening in the academia, in the foreign university, and also now started in the IITs. But yeah, I mean for the local colleges, yeah, definitely it need to be spread at that level. And very I would say very near to our heart, and very our near to our place, PCCOEs. So Pimpri Chinchar College of Engineering. So fantastic progress they have done on the civil things. I mean, concrete 3D printing machines. So I also see this particular things like they along with some IIT professors, they come together and they have developed the 3D printers, indigenous 3D printers, which usually this big companies now using for the 3D printing things, like they are using the cobalt machines, which is almost 10 crores and all. But this indigenous machines is less than 1 crore or less than 50 lakhs, if I am correct. So you can think like how much research they have put into that. Uh, this is not only the PCCOE, but they're along with the type with some IIT and NIT. They have did this work. So, and with seeing that, then there is a Cretebot, which is the one company for the digital constructions. Now they also type with them for making it the more democratizations and also promoting their research to next level. So you can see there is a lot of scope, right? Because the mixture which used for this particular civil itself is a research area, I would say. M40 mixtures which they are using, and people are coming with a lot of different variety of materials in there also, in that cement. So there are a few things like we have to really think, like the layer bonding capacity and all. So that's where there is a lot of opportunity in this area where one can go for uh, the particular research in that material topics. Yeah, and now quickly I will also cover the few things about how we are implementing the COA things before we are really go into the research opportunity and other sectors and all. So that institute also will understand like how it making the difference. So we have created particularly center of excellence model, and our motto here is like we have to make this technology accessible for all the students, because inherently 3D printing is said as like a costly technology and for material machines. But yeah, we wanted to democratize that, and that's where we wanted to make it accessible for all the students, and that's where we have launched these COE models. As you can see, these are the some local colleges only. This is our COE lab types and all. So in this our journey, like we are also collaboration with the DST Prayashala, this science and technology park, giving their certification for the course. So what we are doing here, we are actually the blending the real world problem with the academia. So these are different softwares one can have on that, like the photon. This is actually the resin base. Okay, this is scan 3D is a your scanning softwares. So reverse engineering, by the way, there is lot of application for the industries grade, particularly lot of scope for the faculty for the reverse engineering area. And there are also grant also available. I don't know in India, but in foreign there are a lot of grants for this, like they will come up with some industrial problem and how to solve that problems. So particularly academia institutes are helping there. Then this Tinkercad and Frusa Soy, so you know this for this, right? So and these toolkits, I mean, these all you can see this is machines. These are too enough for the academia as of now, because all machines, remaining machines need a closure environment, I would say, and then this kind of resins are not very easy to handle for the students. So but definitely you can make the foundation, you start building the foundation, and definitely with larger ecosystem like how we have tie up with the COEP, then we can go there and or the auto clusters, so we can have kind of tie up there to see the method theory technology like SLS, how SLM works, how, right? So all other technologies definitely we can see that, and we are the part of that. So basically, our intention is here is to impart the industry oriented skill set among the students, right? And we have a dedicated collaboration with because 3D printing design itself is a big area. To just to tell you that, like 3D printing, we can sell that designs, whatever the designs you are doing, you can sell that designs on some websites. You can actually earn the money. So 3D printing not only just learning things but earning the things. I have clear one case I can remember when we started this 3D Shikshan. So we have one student from the sixth class, and he started doing. I mean, after getting and knowledge from this our course, then he started learning, getting the orders for the customization gifts, 3D printing gifts in gifts like lithophanes and all. So since she has some kind of backgrounds, family background in the business, like her mother was some doing some kind of small business, and then he started helping her for earning. So this kind of secondary earning, even for you faculties also, like this in for research, and as well as this 3D printing design itself is very big topic, because there are some sites where you can upload the designs, right? I mean, for the students, as students, and even once that center of excellence will get income, and also you can do the work for the industry. So there are a lot of things which we can do with the COE. Again, this active collaboration you can do with the these CAD centers. So CAD center usually had the CAD, so modeling software. So instead of that, along with that, you can package with the 3D printing or other stuffs also. That's where I will not go in much detail on this. You can later you can visit it. Yeah, but this is our focus area. So trainings we conduct, workshops, and then AM projects. Like we do the small groups, and we allocate them the projects, and we sponsor the projects also. Few good candidates. So and again the curriculum development like honors and elective subjects. The these things we do. So we are right now working with Sanjani or like there are many colleges where we do this kind of activities. Then on-demand projects, like as I said, like once that COE model, the COE is established, let's say lab is established, so you can utilize it for this. One thing is the enhancing the skills of the students or the faculty. The second thing is earning the and I mean earning opportunities also for the institutes. So whatever consumptions you are investing there, so you can earn that with collaborating with the nearby industry. So you can collaborate with the local industries to like so that is there are a lot of opportunity. We will also see the impact in that we will see, and then internship opportunities. So good students, yeah, definitely we have some type with small scale industries or kind of COEP where there can be the existing opportunity for internship students. An industrial visit, as I already said, like for explore, exploring students to the practical world of the 3D printing industrial level. So we do carry that kind of industrial visits and hackathons. As you know, hackathons, 3D printing is extensively used in hackathons. Either it's in EB or anything. So you know, like these are the teaching aids which we actually these are the all the parts are done by the ITI professors. Okay, we just help them to guide them. So you can see this packaging industry. So it is also paradigmic shift with the 3D printing, and these are the all conceptual level models. So instead of telling this whole mechanism into the abstract format, instead of that, you can simply tell them in tangential object. Right. So what are the impact? So why I'm taking all these things? Because you should also able to understand like implementation of the technology, how it helps in upbringing the your surroundings. So that's where I'm covering these points. Okay. Yeah. So as I said, like NEP is aligned to this mission, and we have almost 20 plus now COE labs across the region. Skill development and career, yeah. So there are a lot of scope for because there is a job scope now, particularly AM design engineers like Honda and all. So they are coming with the job opportunity like AM designs, so additive manufacturing designs. So not the traditional manufacturing because additive manufacturing, as I think Pushkar has partially covered how it differs, additive manufacturing and traditional manufacturing designs also, right? So you are going to optimize the designs. So traditionally you may not optimize it, but in additive manufacturing you have to optimize the design, and also any complex design you can able to manufacture it. So it is giving you the infinite degrees of freedom to design and creating the models. So that's where you are enhancing your skill sets, you are enhancing your design knowledge and manufacturing knowledge as well, because though you are let's say design it, but again everything is not going to 3D print, right? So you will encounter some problems. So you have to change the designs, or you have to take some consideration, geometric tolerances and all these things, right? So definitely because 3D printing, I mean, though it's not a direct geometry tolerance, but 3D printing also subjected to some kind of shrinkage. So that's where like you have to also see like how the mating parts uh, fit into each other. So which will develop your knowledge, I would say. Then and definitely the STEM field, basically students and faculty. This STEM field is lot to do in STEM fields. Different subjects, different things, lot to do in here. And one piece which industry is saying like there is no academia and industries and think skill gaps is there, but definitely if we are able to do some kind of at least connect these two pieces together, I would say an active collaboration. So in this journey, DST Prayashala, SOAP or some MSCB labs are helping us. And as I said, like you can use this for on-demand 3D printing services. So one student know 3D printing, so he can, as I given the example, right? So he can simply use it in your day-to-day life things. Instead of buying the things, you create the things in your own home. You can tell your kids, instead of buying the things, let you print this. So that kind of experiential things already started inculcating right from home. So there were, and even for the COE things like on-demand services. So there are a lot of bureaus which give on-demand 3D printing services like 3D shapes and all. There are institutes also at global level. So where you have to just upload your design and you will get, you have to print that. So if your institute is doing that kind of things, then for the nearby area you can provide and earn also on that. So employment generation will also taking place. So how it is helping supporting local sheep, like a gift shop, I already told, like personalized gifts, idol makers. So the molders things, because they are technically may not be very sound, right? But there is a lot of applications. But that's where like you have to understand where to use 3D printing and where not to use 3D printing. So everybody is saying like plastic injection molding. So maybe 10,000 plus components is okay, but to give that confidence to that industry, right? That you are going to make that component rightly. And if the case is like you don't have much technical knowledge, so there actually 3D printing helps for this molders particularly. So you can quickly show them, okay, this is going to be like this part is going to like this. So that way it enhance your confidence, and that also they wanted to show to their clients. And then jewelry shops, that's where in jewelry also now I think jewelry clusters which making the ornaments, so they have also integral part as a 3D printer. So 3D printer is already come there. Even Ahmednagar, we are seeing some kind of resin 3D printing applications for your ornaments and jewelry, particular things, where you can do a lot of customizations. So customizations is the primary focus for the 3D printing. Instead of going for that's where it is used still in batch, I would say, not like how our plastic injection molding and all use, right? But that is actually helping you for the connecting to the different local businesses and making innovations in there. So definitely COE helps there. Then research and innovation, definitely there are a lot of applications we were going to touch, and basically 3D printing workshops and exhibitions. So it will promote that community engagement things, and you can create a lot of entrepreneurs. So you are the torch bearer as a faculty, and definitely it is going to shine, right? So whatever the business idea students have, if you guided them, then they can validate their business idea working with the ecosystem, surrounding ecosystem, and then a lot of patents things or innovative products, innovative startups, this all fall in line. So I think this theoretical particular part, like how 3D printing incorporated and live case study of our 3D section itself. So which we start just from a simple one lab at Ahmednagar, and now we are actually doing the B2B for 20 plus colleges, setting different labs. So you can see, and actually if you see the COE model, so actually it is helping the building larger ecosystem. So that's where it's helped. Now research topic. Any questions? Okay. So research topic areas, yeah. I also in this presentation I also highlighted few things where you can focus on that. This is more specific on now research things as a faculty, what you can do like material science and development things or biocompatible materials, because this I said like bioprinting, but it is very difficult, a difficult challenge for people to get the different materials which is not hazardous to our own body. So that's where the biocompatible materials, that is medical implantation and prosthetic. So if you see the Sancheti, so they have a separate unit on the prosthetic where they are using the presses, they are printing the presses, which is basically used to for the deformed body, right? So to get in again the proper shape for that, so they are using the braces. Then smart materials like self-healing, shape memory alloy. You must have heard this term, shape memory alloy. So that's where this 4D printing, this all talk about that, like self-healing things. So you can see there is a lot of application in medical industry and skin things, um, uh, where the self-healing things, shape memory things, conductive material in electronics particularly. So nowadays like PCB printing, right? So PCB also getting 3D printed, but they are using that conductive in. So how to make produce that particular material? So that is also one area. So sustainable materials like eco-friendly, because this technology actually reduces all the wastage, right? So this is eco-friendly technology. So it is adding to the sustainable goals, whatever the SDG India is having. So that's where it's eco-friendly technology. Then how you can recycle these plastics? Yeah, there is some scratches also happening with this, but how you can recycle it? Then plant-based resins. So now whatever the resins, right now which resins are there, some chemicals are there. So can you do some kind of bio resins kind of things? So which will reduce this environmental impact, because there are some industrial 3D printers which has complexities, right, to handling the powder metallurgy things, which may cause, nobody has now, I mean, truthfully saying it, but it may cause some detrimental effect on the environment. So can you do such this kind of research in this particular area? So graphene enhance the 3D printing for the stronger lightweight structures, like some example, nanocomposites. This is also very nano things anyway. Now like nanotechnology, they are printing very small things. 3D printing. So there are 3D printers also, which has a nano 3D printers, which are scaling very small level. This is basically used in MEMS, that macro these things, electronics, right? So there are a lot of areas, I would say, and nanocomposite, particularly composites, is having a lot of applications. Carbon fiber composite, CPRP patches and all, which is tremendously used in this your racing cars to given that strength, right? So that's where like graphene things, like carbon things only, right? It's a part of the carbon. So how you can enhance the strength? So you can see now more electric aircraft. So that aircraft is now having maximum component of 3D printing, or rocket, 3D printing rocket, which this Agnikul has fired, and ISRO helped them. So 3D printing engine itself. So all these things, you can, this can be one project area itself. Okay. So medical applications, yeah, definitely. Just a minute. Yeah, 3D bioprinting. As I said, like there will be times in the future, I think down the line 4 or 5 years, when you will see some kind of tissues on some kind of non-vital organs. They will start. So instead of doing the research right now, what they are doing on animals, so they will, and that cycle inherently very long time. They have to take a lot of trials. So with the combination of AI, 3D printing, so this time going to reduce, and at least for the non-vital organs, this is going to replace. So this is going to help for the humanity, for this organ transplant, because there are some cases like organ transplant failures. So we can easily identify if particular, because this is a customization now again, that particular body is receptible for this particular organ. So all different applications, the surgical models, custom implantation, personal implantation, specific criteria. Why now Sanchiti is using? Because once they scan their foot, so every foot is having different thing. So you can simply replicate it, right? So dentistry. So when in dentistry applications like that, tooth liners and all. So now invisible tooth liners are comes, which is not feeling awkward while moving in the society. Earlier, we used to see the kids with having some kind of visible liners. Innovation not happened that time, but now it's starting happening. So like this thing, the drug delivery system. So the future is like we will have the polypills. Polypills means one pills combining all the diseases, different. Let's say you have headache, you have nausea, you have I mean there are different things. But in market, if you go to the chemist shop now, you have to purchase different tablets for each. Even doctor also prescribes it like a 3 4 tablets, and it's difficult for the children's. Okay, if they have some kind of acute symptoms, very difficult for them. I personally experienced for myself. and for elders also. So there actually 3D printing is using as a polypill technology. So polypill basically they are creating. So with the help of FDM and there are some other technologies, right? Some resin technology and other technology also. So multi-jet printings, there are a lot of technology, polyjet printing technology. So with the help of this, so drug delivery system itself is a big area. So if you see seeing the research, if you see the papers, you just Google it out. So you will see n number of papers on the drug delivery things, like how 3D printing basically now, because the way that particular pill or drug getting dissolved in our system, that itself is a research thing. I mean, it's itself is a paper research work. Like what is, and people have done that, like a case study of particular, like whatever tablet when we dissolve. So when it is going to absorb in our body, and how we can reduce that, so how we can make it more comfortable for the kids, adults. So like this there are a lot of things for the drug delivery thing. I know this is some research topics and this is going to time, but in future it's definitely going to time. Like artificial skin is these burn victims, so there are cases people are using it to some extent, maybe at foreign things, but yeah, but you will see lot of application in coming area. And orthopedic implants is already happening. So doctors are using extensively 3D printings, and that's where in bio 3D printing is very very important topic. Very complex cases like where the spinal cord itself having some kind of curvature, and it's very difficult for doctors to get that confidence without. So 3D printing is actually acting as a supplementary. You understand? May not be direct, but supplementary skills. So doctor can get the trial on the model, okay, that anatomy model, and then he can go with very confidence, like where I had to insert the screw, where I had to do the surgery, and to much what the level, and so that patient will not feel any harms. So in that area you have to, I mean, 3D printing is using extensively, and these are all topics for let's say bio 3D printing. So tissue, organ, prosthetic, the, these are all the topic for the research, because technology is not full fledged. Otherwise, would have been seen everybody, everything. But it is still lot of gaps are there. The gaps in terms of materials, the gaps in terms of the technology. Sometimes giving some side effects also can possible, right? If you are inventing something, so there it is definitely. Then industrial application, as you already know, the drone and 3D printing, by the way, very very connected together, and that's where now spacecraft, where it is for human, it's difficult environment. So that's where like the Siachen and also now bunkers they are making with the 3D printing, right? Because the environment which is hazardous to human, but machine can operate. So that's where it is going further and autonomous production, and that's where the spacecraft, or you can see there are a lot of startups nowadays in the 3D printing or in space which utilizing the 3D printing, and that's where now whole rocket which has a more than 1,000 components, now they're single single component they are printing with the help of DED technology, direct energy deposition. That company Agricola has done that. So like that there are a lot of, but when this invented, so some kind of research, right? So these are all the opportunities. So applications and learnings hands together, right? So you may have seen these all examples also, but I'm just experiencing you again. Then electronic printing, as I said, like PCB, then sensors, antennas. By the way, lot of advancement is happening in the antennas because of the your 5G things, right? So lot of scopes, like how 3D printing I mean how 3D printing helps in here, or for the research particularly, right? Where I to place the antenna. So you have to do some kind of trials, right? What you gonna do on the things which is very costly. Then you have to use 3D printing as a prototypes, as a rapid prototypes, like that. So large scale 3D printing homes, as I already said, concrete materials, multi-material printing. So multi-material, like technologies are there. So where you can insert different inks, and then you can print it. Then education, as I already said, this is very powerful pedagogy tool. So in chemistry, biology, and all, so you can utilize in STEM. Then adaptive learning tools, basically the braille, like visual impaired students, right, or persons. So you can use these tactile models, then braille lipi, like even braille now, what we are talking, that pills, right? So to just to have the customized pill, so polypill and all, so they are using braille things also for, I mean, for the visual impaired students. So there is a research is going on, like how we can make it available pills for the, let's say, how they can identify easily, since they cannot see it, the name of the tablet, but by just experiencing the texture of that. So there actually 3D printing use. Then gamification of virtual reality. Virtual reality is very, very closely associated with the 3D printing, and combination of these two, 3D printing and AR VR. So it is going to create, I mean, it has already started doing that paragonamic shift and that altogether different experience which student can have for the learning the complex concepts. It's already started, like gamification things, virtual reality. So you can easily see, it is not possible for you, right? I mean, student to experience like how complex aeroplane structure is. But with the help of this, you can actually, you can see, there are some gadgets, right? So with the help of that, you can easily see. So all these things, and 3D printing, see, AR visualization and 3D printing helps in making it in reality. So like that combination is used. So I would say like if 15 years of 3D printing, yeah, I already told this. An integration of AR with the immersive learning experience, right? So immersive, there is a lot of learning experience. Then robotics and AI integration, like soft robotics. So flexible robotics, as I shown there, right? In one of the case studies, which is making of the flexible resins. So kind of that. Then I already explained this, like machine learnings we can use for the optimize the print quality, because this is inherently difficult for low end printers, print quality. So how we can utilize that? You can also have kind of project for that. Then autonomous manufacturing, yeah, self-repelling, self-assembling printing parts. So this is kind of the 4D printing, I would say, but yeah, it will definitely topic. So AI-based predictive modeling of the 3D printing for failure detection. As I already said, there are a lot of failures. 3D printing is a difficult technology. I would say like a plug. It's not a plug and play. You have to. It's like how you drive your motorcycle or car. So first gear, it is going to give you trouble, but the down the lines, when you have experienced that, then will have smooth rides. So similarly with 3D printing also, initially the 3D printing failures, and with the new material, new machines, new specifications, it is a challenge, and that's where like AI, with the help of AI, we can minimize that challenge. Then this biomimic robotic limbs. So biomimic, like what I shown there, like different degrees of motions can be possible with the help of that kind of biomimic robotics limbs. Yeah, so you can utilize. Then environmental sustainability and recycling, like this is very huge area, using recyclable and biodegradable materials. Then plastic weights, yeah, the ocean things, yeah, you know this. There are one startup actually. They are actually collecting this. They have make developed the mechanism which collect that plastics from the ocean using some 3D printed parts. So it is possible. So there are a lot of research. And again, solar power 3D printing, like energy efficient panels, this solar power 3D printers basically. So machine material. So either you can do research in your materials, or machines also, like how you can, because these 3D printers consume lot of electricity. So then how solar power can use. So combination of different technology, different areas, you can do the research things. Development of biodegradable filament. Yeah, this is eco-friendliness everybody want. So then like how to do recycling things, right, for urban infrastructures. So if you see, like we are focusing on the eco city, eco things, then how 3D printing fit into that. So you can have one kind of test model itself with the help of students, and then you can show. So like that, there are a lot of things. Then already said the food technology and edible 3D printing, right? So basically, the 3D printed food tailors for medicals and dietary needs. As I already told, there is a pills. Similarly, where there is nutritions also, right? So then there are some 3D printed foods also. but it's still in research area where they have done some lab grown meat and plant based proteins, but it is still in research area. But there is huge scope for the research, and because this is going to application in where the space, right? Space particularly. So that's where astronomers also using, and they are now carrying the 3D printers with them for a different purpose. But yeah, definitely. So 3D printing of the personalized nutrition dense meals for the hospitals. So as I said, the 3D printing helps in customization. So it will be that like whatever based on the prescriptions. But what about the nutrients? So whatever the basically the personalized nutrients, right? So based on that, in the future you can able to give serve this kind of things like nutrient enrichment meals, right? That's where 3D printing is just started in the hospitals, but you can utilize it in different applications. And then exploring the plant based in for the sustainable food printing, again SDG, like eco particularly, like what are the different materials. So there is a limitless potential, I would say, right, for biomedicine, aerospace, education, sustainability, where 3D printing extensively you can utilize. There is another things. Yeah, we are I think running short of time, but I will quickly check this. These are the resources now. Whatever so far we have seen the areas, now is the resources like already applications. So science and engineering research boards grants. So they grants it SARB. So biomedical applications. Okay, I will quickly cover this. The Department of Science as I already taken. So science technology. These are the funding opportunities for the advanced manufacturing and digital fabrication projects. Then AICT, that's where like AICT implemented 3D printing now in first year itself. So there are a lot of promotion is happening for AICT for faculty research engineering applications of 3D printing. Then DRDO, which is our Defense Research Institute. So there are also some kind of grants, fund projects available in 3D printed defense equipments or unmanned vehicles, battlefield solutions. Examples you can see here, the lightweight aerospace components, then development of eco-friendly and biodegradable 3D printing filaments, and AI-driven optimization of 3D printing process. Then industry collaboration, if you see corporate, also a lot of things happening like at corporate level also. All this Bharat Forge or G additive, they are doing extensive research in this area, and they also offer the sponsors research. I mean, together with that, you can conduct the research. So that kind of things. Then intake additive solutions, the collaborative university for next gen material, as I already said, next gen material, next generation material. Tata Technologies support research on automobile or industrial applications of additive manufacturing. Then materialize, it's a material I materialize, provide research-based collaboration in medical 3D printing, particularly implants and prosthetics. So then example industries focus research areas. So like already electric vehicles, lot of applications, and we will not again going to talk about this patient specific implants. I already explained, but using metal 3D printing, right? So you can see the IIT Madras, IIT Bombay, IIT Kanpur, IITs. So all this they are having the center of excellence in additive manufacturing, the biomechanical engineering technology innovation centers. National Center of Flexible Electronics focuses on the 3D printed flexible electronics and circuit. So you can easily collaborate with them and have your research thesis done, right? Or some kind of COE established at your institute. So 3D printing robotics labs, AI integrated 3D printing for automation. So examples of collaborative research area like disaster relief shelters, affordable housings, then robotic assisted 3D printings for smart manufacturing. So even international fellowships also there, like Fulbright, Nehru Academic Research fellowships are there. UK, India is also providing some kind of collaboration, right? So there are a lot of opportunities, I would say. Bioprinting of the tissues and artificial organs of the transplantation, then development of the high performance ceramics, because ceramics extensively used in aerospace. So how we can enhance the performance of that material, right? Then you can see here this MEIT tied 2.0 schemes. As I said, like government also doing a lot of things. So you can see this provide the faculty with the funding to commercialize the 3D printing innovations. Then ISC Bangalore, which is the center of the excellence in the 3D printing. So their product design and manufacturing, their support in digital fabrication and additive manufacturing. Then again, DST Nidhi Prayas, yeah, for early stage startups, and uh, they already funding it, right? So customized 3D printing medical implants again, and low cost prosthetics, because prosthetic inherently very costly. So how rural healthcare get strengthened with this. Then academia, I think we have already covered this, but Institute of Chemical Engineering, so they are doing some fantastic research in the pharmaceutical science and technology, pioneering the 3D printing, bio 3D printing and all, right? So then MGM University, which is very close, Aurangabad. So Stasis is one of the manufacturer. They are enabling the aeronautical and biomedical, again the biomedical research, right? So government initiatives, government also, this NEILT, this is National Institute of Electronics and Information Technology, Aurangabad. He established 3D printing labs offering the certification courses. There is certification course also, and they're also fostering the research and skill development in this, right? Then again, ATL has already talked about that in school and colleges. ATL has. So how faculty can apply these opportunities, like identify the funding agencies, like explore the grants from these different institutes, then collaborate with industry and academia, so partner with IIT, IC, and ITs and companies like GE additives, Tata Technologies, and develop the strong research proposal. So important thing is you to, again, this is a skill, like how to draft that research proposal. And yeah, I'm sure you were all aware of that. And then identify the area of the healthcare of the 3D printing applications, aerospace, sustainability, and robotics. And then engage with the research communities. This is also important, like how you can engage with all the communities, and which will drive you the advanced trend of the technology, so where it's heavy. So in short, I will come to end of the presentation. So the AM workforce, if it is not only the manufacturing, it is not the designs, it's a combination of all. So on the personal side also, it's a combination of creativity, analytical decision making, active learning, then entrepreneurs, communication skill, elasticity, I mean complex problem solving skill. And this side is application side, like commercial, you should know applications, then design also, then experience of verticals, I mean different applications, so different workforce, and manufacturing, and the technology, of course, like which technology, where to use. So as a faculty, yeah, I mean where to use this technology, or how you can strengthen the ecosystems. So for that, it's very important for you to learn the 3D printing and also understand its limitations also. These are some, I would say, like enhancement resources where you will get lot of material, which partially I use in the presentation. Lot of things I use here. So specifically this 3dprinting.com or all3dp.com, and then 3dprint.com, they have podcast also. Okay, so you can understand. And this podcast is very nice actually, like because it is also for the entrepreneurs or also for the faculties. So there are renowned faculties, so they experience their struggle with the 3D printing technology, and also they say now how they have achieved in the 3D printing areas. So, and these two magazines, which is I mean India based only, manufacture 3D mag and amchronicle.com. So this also, I think, very helpful for you guys to understand the different types of technology, what is the advancement is happening. So overall, I think, yeah, these are all things I wanted to cover. I mean, it may be a little bit theoretical because the topic itself is like that, but I would try to touch upon the different applications of the research also. So I think questions and answers, the floor is open for that. Yeah, if anything. Hello.
Yes, sir.
Yeah. So
Hello.
floor is open if any questions related to anything. Else we can conclude.
Hello, is my voice is audible to all of you?
Yes, sir.
If anybody has any question, please ask to Mr. Prashant sir.
I hope it is
Okay.
not too much, right?
Yes. No, no. I think your explanation is so too good that so any don't have any doubt or any questions.
Okay, fine, no issue. Thank you, sir.
Okay. So on behalf of Gokul Education Society, so Dr. M.S. Gosavi Polytechnic, I thank you, Mr. Prashant sir, for enlightening our sessions, for being integral part of our learning experience. So very, very thank you for that.
No problem, sir. Welcome.
Okay, thank you.
Thank you. We'll close the meeting then.
Okay.
Okay, thanks.
And one note for the remaining